Okay, so we have started looking at methods. Methods of differentiation. Then we did the first method. Now our second method is power law. If you understand this rule, all other rules becomes a giveaway thing, because it will appear in every other rule. So if y is equal to x to the power n, then the derivative of y is equal to n x to the power n minus 1. This is called power rule. Even if we had something like a x n, the derivative is going to be a multiplied by n x to the power n minus 1. That's power rule. Third, we look at chain rule. This is a summary of all the rules. So if y is u to the power n, where u is a function of x. I thought it was a question. Where u is a function of x, then the derivative dy dx is equal to n u to the power n minus 1 multiplied by the derivative of u. With respect to x. This is called chain rule. Or product rule. If y is equal to u multiplied by v, where u and v are functions of x, then dy dx is equal to u prime multiplied by v plus v prime v prime multiplied by u, and then 5 quotient rule. Quotient rule: if y is equal to u over v, where u and v are functions of x, then dy dx is going to be u prime v minus v prime u over v squared. This set of 4 rules plays a very, very important role in calculus. Without power rule, you cannot have chain rule. You cannot have product rule. You can't have quotient rule. Because you have seen that every other rule is going to be using power rule. So now,
Excuse me, sir. I just wanted to find out on the chain rule because uh, the first part where it's saying n u to the power n minus 1, it seems to be, it has been, uh, they've found the derivative of that function, and also the u seems to have that prime thing. Does it mean the u also you need to find the derivative?
we find the derivative of u because we are saying u is a function of x. It's not like x. It is a function of x, like 2x squared plus 4. That is u to the power 7. That is n. So you'll see when we do examples, what we mean by u being a function of x, and then differentiating by treating the power first, and then getting to the actual function, which is u.
Sir, on the
Hello?
power rule, there on the y
Mm-hmm.
prime, why are we only differentiating x? What about a? Why are we not differentiating?
It's a constant. It's just a coefficient here. So that if you try to use product rule, other piece will be 0. Remember that we
Huh?
differentiated the constant using first principle, and we got that its derivative was 0, is it?
Yes.
Yeah, so if you take that as the product and then differentiate the two pieces using product rule, you still arrive at the very thing, because the derivative of a will be 0. So 0 multiplied by x to the power n will still give you 0. So you rely on a multiplied by the derivative of x to the power n.
Okay, I get it.
So let's bring a set of examples. Find dy dx a y is equal to which is here, y is equal to 4 b y is equal to 5x to the power 7 minus 3x to the power negative 4 plus 10x minus 7. So let's do these two. We'll call this question 1. The derivative of the constant is 0, because remember that when you are doing binomials, we said this number here can also be written as 4x to the power 0. So if you use the power rule, you have 4 multiplied by 0 x to the power 0 minus 1. So we get 4 times 0 is 0. That's how we get that derivative there. And then for b dy dx, as usual, 5 multiplied by 7 x to the power 7 minus 1 minus 3 multiplied by negative 4
So
x. Hello?
please, can you take it back to the previous page? This is when I've just joined.
This is the page. Very, very important for today.
Thank you, sir.
So, x to the power negative 4 minus 1 plus 10, 1, x to the power 1 minus 1, and then minus 0, the derivative of 7. 5 times 7, we get 35, x to the power 6. This becomes plus 12, x to the power negative 5, and plus 10, x to the power 0 is just 1. So we just get 10 there. That's how we find the derivative. We have used power rule throughout. C y is equal to x plus 4 over x. Differentiate it. So we are saying we can write this function as x plus 4x to the power negative 1. Because x is in the denominator and it is to the power 1, when we take it up, it will go up with a negative power. And then dy dx is the same as 1 minus 4x negative 1 minus 1. So we are getting 1 minus 4x to the power negative 2. This is 1 minus 4 over x squared. You can still take back the 2 in the denominator and it will go there as the positive power of x. So example number 1, trying to explain what the power rule means. We do example number 2. Find f prime of x. A, f of x is equal to 3x to the power 3 minus 4x squared.
Sorry, sir. How did the sign change from positive to negative on question C?
Is
From x plus 1, oh, x plus 4x to 1
so
minus 4.
so it became this, is it?
Yes.
Then when differentiating, the derivative of x is just 1. And then the derivative of 4x to the power negative 1, we drop the power. So we'll have 4 multiplied by negative 1, x to the power negative 1 minus 1. And then there's a 1 here. So this turns out to be 1 minus 4 x to the power negative 2, which I've written as this. Is it okay?
Yes, sir. Thank you.
Okay. So this is A, B, f of x is equal to negative x to the power 7. Maybe we put something else, negative x to the power 1 over 3 plus 4x to the power negative half, everything in the square root. We differentiate. For A, f prime of x is going to be, or we can do it slowly, we let u to be 3x to the power 3 minus 4x squared. And then differentiate u, we'll get 9x squared minus 8x. From there, we'll go back to f and write f as u to the power 10. We understand that its derivative is going to be 10 u 10 minus 1 multiplied by u prime, because we know u is a function of x. That's what the chain rule says. Then now we substitute what u is. So we have 10, u is 3x to the power 3 minus 4x squared. 10 minus 1 is 9, and then multiplied by u prime, 9x squared minus 8x. That's what we meant by u prime. Because every part must be touched when you're differentiating. So you differentiate the power first, keep everything inside the brackets fixed, and then when you're done with the power, go inside the brackets, differentiate everything that is there. For b, we can write this function as negative x to the power 1 over 3 plus 4x to the power negative half to the power half. We know the square root is also half, and then we let u b negative x to the power 1 over 3 plus 4x to the power negative 1 over 2. And then differentiate u, we'll get negative 1 over 3 x 1 over 3 minus 1 plus 4 negative half x to the power negative half plus 1 minus 1. We simplify this, we get negative 1 over 3 x to the power negative 2 over 3 minus 2x to the power negative 3 over 2. And then we can write f of x as u to the power half, so that its derivative becomes half u to the power half minus 1 multiplied by u prime. When we substitute in the next space, so when we substitute, this is equal to half u is negative x to the power 1 over 3 plus 4 x to the power negative half to the power half minus 1, we get negative half, and then u prime is negative 1 over 3 x to the power negative 2 over 3 minus 2 x to the power negative 3 over 2. This becomes the derivative of f. This is how we use chain rule. So you make sure that every piece of the function is differentiated. You start with the power, fix what is inside. When you are differentiating a certain part, the other parts you're not differentiating will remain fixed. So when differentiating the power, you leave the function inside as it is. When you're done with the power, you leave the power as it is and differentiate what is inside it. So another example, example 3, find the f, the x, f of x is equal to 3x squared minus 1 multiplied by 4x to the power 3 minus 7x to the power 4. So this is a product. If you attempt to start squaring, to start expanding, you have a lot of work. B f of x is equal to the root of x plus 1 multiplied by 1 over 3, multiplied by cube root of x squared minus 2. Solution, we have A, that's a product, so direct away we let U to be one of them. v to be 4x to the power 3 minus 7x, everything to the power 4. And then differentiate u, we'll get 6x. Differentiate v, we'll get 4 multiplied by 4x to the power 3 minus 7x. 4 minus 1 is 3 multiplied by, we differentiate now the inside of 12x squared minus 7. Then we are saying the x is equal to u prime v plus v prime u, meaning that u prime is 6x, v is 4x 3 minus 7x to the power 4 plus v prime is 4x 3 minus 7x to the power 3 multiplied by 12x squared minus 7 multiplied by u, which is 3x squared minus 1. And we are done. No much simplification is needed when you are told to differentiate. For b, we let u be x plus 1 to the power half, so that its derivative becomes half x plus 1 to the power negative half multiplied by the derivative of x is 1, and derivative of 1 is 0. So we get that, and then we let v be x squared minus 2 to the power 1 over 3. The derivative of v is going to be 1 over 3 x squared minus 2 to the power negative 2 over 3 multiplied by 2x, derivative of the inside. And then the x is equal to u prime v plus v prime u. This is the same as half x plus 1 to the power negative half multiplied by v, which is x squared minus 2 to the power 1 over 3 plus v prime, which you can write as 2 over 3x multiplied by x squared minus 2 to the power negative 2 over 3 multiplied by u, and u is x plus 1 to the power half. So this becomes the derivative of f for b using product rule.
Excuse me, sir.
Okay.
And the answer, the last part of the answer, you've written 2 over 3x. Is it not supposed to be 1 over 3?
So it's supposed to be 1 over 3, but then there's this 2 here. So I'm multiplying 1 over 3 by that 2x. Also, I've written it as 2 over
Okay, I've seen.
3x. Okay.
Sir, On A, when you are finding v prime, you use chain rule.
Yes.
Okay.
So but you have seen that in every rule we have used power rule. So these rules will be coming in. So you find yourself doing product rule, using product rule, but in product rule, when you try to differentiate the pieces, you find again they're also relying on chain rule. Chain rule relying on power rule. So example 3. Example 4.
So a minute, let me just.
So she's done.
Sure, sir.
Okay.
I know her, sir.
Yeah. So y is equal to 3x plus 1 over x squared minus 10. B, y is equal to 4x squared multiplied by x plus 4 to the power 2 over x to the power 3 over 2. Solution. For the first one, you can see that's a fraction. So whenever you have a fraction, you use quotient rule. So you let u be the numerator and v be the denominator. And then differentiate u, we get 3. Differentiate v, we get 2x. And then find y prime, which is u prime v minus v prime u over v squared. This is u prime is 3, v is x squared minus 10 minus v prime is 2x, u is 3x plus 1 over v squared is x squared minus 10 squared. So it looks like this one is nice to simplify. So we'll have 3x squared minus 30 minus 6x squared minus 2x over x squared minus 10 squared. And the other step will be negative 3x squared minus 2x minus 30 over x squared minus 10 squared. We go to B, so this was A. B, let u be 4x squared multiplied by x plus 4 squared, and v be x to the power 3 over 2. When differentiating u, you use product rule. So you first differentiate 4x squared, we'll get 8x, then multiply by x plus 4 squared, and then we add, we differentiate x plus 4 squared, so we'll drop 2, we'll have x plus 4 multiplied by 1, the derivative of x plus 4, and then multiplied by 4x squared. If we simplify this, it will be 8x x plus 4 squared plus 2 times 4, we get 8x squared, and then x plus 4. Then we go to v and differentiate v. We drop the power and remain with x, 3 over 2 minus 1. This is the same as 3 over 2 x to the power 1 over 2. Then y prime is going to be u prime v minus v prime u over v squared. That is, u prime is 8x x plus 4 squared plus 8x squared x plus 4. This whole thing is u prime multiplied by v, which is x to the power 3 over 2, minus v prime 3 over 2 x to the power half multiplied by u, which is 4x squared, x plus 4 squared, and then we close everything over v squared to just come out as x to the power 3. Since when you multiply x, 3 over 2, when you square this, these two will cancel, and you have x to the power 3. So we have this as y prime. We have used quotient rule.
So this means it's more likely kubompya fedha ino bamperere than to change it. Like I'll give an example. First example, yachkwata 3x plus 1 then over x squared minus 10. Nga twalichinjisha yakwe bati twaibika in a form of therefore kuisolve in a form of product rule. Will it work? Or kuisolve vivra fino for bamperere?
It can work, but the difference is the same.
Sir,
Hello?
so is it that wherever chain rule is involved, you have to use the other rule before chain rule? Like how product rule was used before the chain rule?
The chain rule was involved in this case together with the product rule. That's why we went for the product rule. If it was not a product, would have just involved power rule in the chain rule. But now the x plus 4 to the power 2 is being multiplied by 4x squared. So you can't just go for chain rule because there's a part that will leave out without differentiating. So you need to touch every part.
right, I get it now.
Okay. The next method, method 6, is called implicit differentiation. Implicit differentiation. Okay. This one, if you observed in the previous rules, when you have y is equal to 4x squared, for example, and we are asked to find y prime. Now y prime is the same as dy dx. Okay, so what we do here is, for you to move from this step to y prime, you actually differentiate y as if it was x. When we say the derivative of x, we get 1. So when we say dy dx, you first differentiate y, you get 1, and then you multiply by dy dx, because you have differentiated y with respect to itself when you're actually supposed to differentiate with respect to x. And then on the right, you differentiate x 4x squared with respect to x, so you get 8x. But 1 times dy dx still remains dy dx, which is 8x. Now, the point here is that you can still do this even if y was squared. Suppose you had y squared is equal to 4x squared. Instead of solving for y, you could just differentiate y squared as if you are differentiating x squared. So you say 2y, but because you have differentiated y squared as if you are doing with respect to y, you multiply it by dy dx, and then differentiate 4x squared with respect to x, you get 8x. So you divide by 2, you divide by 2y. So your function is going to be dy dx is equal to 8x over 2y. So this method where you don't bother yourself to solve for y, you just differentiate y wherever it is, and just remember to multiply by dy dx every time you differentiate y, is what we call implicit differentiation. It doesn't have a formal way of writing it, just like we write this here. For it, if we are to force it to be formal, we'll just say, if you have a situation where you have y to the power n is equal to some function of x, then you would say, to find dy dx, you would say you have ny n minus 1 dy dx is equal to f prime of x, and then leave dy dx alone, equal to f prime of x divided by n y n minus 1. Yeah. We have such a thing. If we force it to be formal.
Excuse me, sir.
Uh,
Can you repeat the explanation on just starting from y squared is equal to 4x squared? How to let dy dx the subject?
so the first thing you do is you treat y squared as if it is x squared and use power rule on it. So differentiate y squared using power rule, it's going to be 2y. But y is a function of x, so you multiply it by dy dx. and then differentiate 4x squared with respect to x, so you have 8x. And then you are solving for dy dx, so you divide throughout by 2y and by 2y. So let's do examples of it so that we see it properly. Examples. Find dy dx. A, x squared plus y squared is equal to 4x plus 3y to the power 3 plus 5y. And B, negative x squared plus y squared is equal to 1. Solution. So say, okay, this is not a difficult thing. Instead of us trying to solve for y, which may be so difficult, if not impossible, manually. So say, okay, this is just the same as differentiating x squared, we'll get 2x. Differentiating y squared, we'll get 2y. But because it is y, we multiply by dy dx is equal to differentiate 4x, we get 4, plus differentiate 3y to the power 3, we get 9y squared. But because it is y, we multiply by dy dx. Plus differentiate 5y, you get 5. But because there was a y, you put dy dx. And then you are solving for dy dx, so you put together all the dy dx. Anything that has dy dx, you collect them and put them one side, and everything else you take to the other side. So this implies that we will have 2y dy dx minus 9y squared dy dx minus 5 dy dx is equal to 4 minus 2x. And then factor out dy dx. You get 2y minus 9y squared minus 5 is equal to 4 minus 2x. This means that dy dx is equal to 4 minus 2x divided by 2y minus 9x and minus 9y minus 9y squared minus 5.
Kwasira.
Yeah, kwasira. Wamana.
Simone Nzuga.
So that's how you do the derivatives here. So this was A. Let's go to B. You differentiate negative x squared, so you have negative 2x plus differentiate y squared, you have 2y, but because it is y, you multiply by dy dx is equal to 0. This means that we have 2y dy dx is equal to positive 2x. Divide by 2y and divide by 2y. So you get dy dx be equal to 2x over 2y, which is equal to x over 1. Where are the negative gone? Oh, we took the other side. Okay. So this is what we call differentiation. So in here, calculus derivatives, these are the only 6 methods that exist on derivatives. These are
Sir,
the
I've
only
got an
methods
example in
on.
implicit.
Yeah, bring it up.
Open bracket, x minus
Uh-huh.
y, close to the power 4, is equal to x plus y plus 5.
So solution.
Excuse me, sir.
Mm-hmm.
Can you repeat the previous page?
You want to screenshot it?
I have, thank you.
Okay. Okay, so here we use chain rule for this piece. We first drop the 4 and keep everything else inside. 4 minus 1, we get 3, multiplied by the derivative of the inside. The derivative of x is 1. The derivative of negative y is negative 1. But because it is y, we multiply by dy dx is equal to derivative of x is 1, derivative of y is 1, but because it is y, multiplied by dy dx. So let's be muted. Good. Then we expand. Now in our expansion, we don't need to break this. We just want to break this here. So we have 4x minus y to the power 3 multiplied by 1. We'll get 4x minus y to the power 3 minus 4x minus y dy dx, which is equal to 1 plus dy dx. And then we take this guy the other side and this one the other side because we're looking for dy dx. So we'll have negative 4 x minus y dy dx minus dy dx is equal to 1 minus 4 x minus y to the power 3. And then we factor out dy dx, factor out dy dx, then we'll have negative 4 x minus y minus 1 is equal to 1 minus 4 x minus y to the power 3, and then divide by everything. We remain with dy dx is equal to 1 minus 4 x minus y to the power 3 over negative 4 x minus y minus 1. So this is the derivative. The thing of factoring out the negatives on the right is having time. If you have time, you do that. But if it's your first question, you should always know that we're just starting and you have so many things to do. So if you leave it there, you lose no mark.
Yeah.
So
Okay, let this first.
On the second step, where is the negative 4 coming from?
Where is the negative 4 coming from? On
Yes,
the
in figure
second step.
4.
So we expanded. So here we're expanding. We are multiplying this whole thing by 1. We got this. Again, this whole thing by negative 1 dy dx. So the negative multiplied by positive 4, we get negative 4. And then everything else follows.
Sir, can you explain again?
Okay. Let me pick that question from, let me stop from talking there, so that I answer 2 at a time.
I see Asaka was more somebody this face.
That's what the constitution says. Okay. Uh-huh.
So let's say if we expanded the 4 to the other side, it would be wrong. Like we like not touching x minus y to the power 3, but then just expanding 4 times y minus 1 to the power.
And this one here is to the power 3. This is to the power 3. Where is it?
Not 3, it's 4, sir. To the power 4.
To the power 3. What's have
Oh,
Sir,
differentiated this?
how,
we are
sir?
just differentiating the inside part instead. Tatureika takuri power, basa.
We start by touching the power before we go to the inside.
For the power,
No,
it's
sir,
that
you can
one.
go back then.
Look, what we have is x minus y to the power 4 is equal to x plus y plus 5, is it? This here is like u to the power 4. When you differentiate it, you say 4u3 by u prime. So we'll say 4x minus y 3, and then u prime, we differentiate x, we get 1. We differentiate y, so we have minus 1 multiplied by dy dx is equal to, we differentiate x, we get 1. We differentiate
The
y,
power,
get dy
basa.
dx. Which power?
You said to the u prime.
It is u prime, guys.
Yes, sir. You confused us. You said you are supposed to put a power.
No, look. Then here we expand now. What is this multiplied by 1? We'll get 4x minus y to the power 3 minus, what is this multiplied by dy dx? We'll have 4x minus y to the power 3 dy dx is equal to 1 plus dy dx. Here we're just expanding this by this. That's all we're doing. Okay? And then, hello.
Oh, okay.
And then we take this side and this one the other side. So nothing will change as we take the other side. So we'll have negative 4 x minus y to the power 3 dy dx minus dy dx is equal to 1 minus 4 x minus y to the power 3. This one. Then we factor out dy dx. We remain with negative 4 x minus y to the power 3 minus 1 is equal to 1 minus 4 x minus y to the power 3. And then divide by negative 4 x minus y to the power 3 minus 1. Divide by negative 4 x minus y to the power 3 minus 1. So we remain with dy dx is equal to 1 minus 4 x minus y to the power 3 over negative 4 x minus y to the power 3 minus 1. Exactly what we have here. Same method. Same everything.
Hello, sir.
Hello.
Yeah, I think we can try this one.
Is another one?
Yeah.
Okay. D
The root of xy plus x plus y squared is equals to 0.
the derivative of a constant is 0. So whether we're differentiating 0 or any other constant, we still get 0. Then we can write the first part as x to the power half, differentiate it as half xy, half minus 1 is negative half, and then this we differentiate as product. So if first differentiate x, we get 1. So we'll have 1 times y, which is y, plus we differentiate now with respect to y, so we'll have x, but because it is y, we'll have dy dx. So we'll get this, represent the first part here. So we'll have half negative, we'll have half xy to the power negative half multiplied by y plus x dy dx plus we differentiate x, we'll get 1, plus we differentiate y squared, we get 2y, but because it is y, dy dx is going to give us 0. Then we factor out, before we factor out dy dx, we first expand because of this bracket here. So first expand, so we'll have half xy to the power negative half y plus x over 2 root xy dy dx, and then plus 1 plus 2y dy dx is equal to 0. So what we have done here is we have written this guy we've taken it back in the root, but because its half is negative, we've taken it in the denominator. And then this x here, we're multiplying 1 by this x. That's why we have the x as a numerator. And then we're interested in dy dx, so we factor out dy dx. So we have x over 2 the root of xy plus 2y is equal to, we take 1 the other side as a negative, also negative half xy to the negative half multiplied by y. And then divide by everything, so dy dx is equal to negative 1 minus half xy to the power negative half y over x over 2 root xy plus 2y. You can leave it in this form, or you can decide to write the numerator as negative 1 minus y over 2 root xy, just like we wrote the other one in the denominator, and then here have x over 2 root xy plus 2y. Like that.
So, sir,
Mm-hmm.
there is no way they can give three functions multiplying.
Even if they give them as 3 functions multiplying, you take them in 2 tools. For
Okay, there's
example,
another example.
okay, let me give one based on the functions multiplying. You can have x squared multiplied by x plus 3 to the power 4 multiplied by x minus 1 to the power 7. This is equal to y. To differentiate, since there are 3, you take them, you take u to be the first 2, and you take v to be the other one. You have issued differentiating u, you are going to have 2x and fix the other one, because when differentiating u, you use product rule, plus you drop 4, maintain x squared multiplied by x plus 4, x plus 3 to the power 3 multiplied by 1, which doesn't change anything, and then v prime is going to be 7 x minus 1 to the power 6 multiplied by 1, and then dy dx, as usual, y prime v plus v prime u. U prime is here, so you take it as it is, x plus 3 to the power 4 plus 4x squared x plus 3 to the power 3. This whole guy multiplied by v, which is x minus 1 to the power 7, plus v prime 7 x minus 1 6 multiplied by x squared, which is u, x plus 3 to the power 4. We are done. Even if it was as a fraction, it's to separate in that manner, whether your u or your v, and still carry on, get to the solution.
Me have a question on
Yeah.
part D.
On part D.
I don't know how you differentiated the x, y, which is in the bracket there.
You use, when you have x, y, you take it in the same way we take u, v. So you let your u to be x and your v to be y. When you differentiate u, you get 1. When you differentiate v, you get 1 multiplied by dy dx. But you know that 1 multiplied by anything is that thing. And then you write it as u prime v plus v prime u. So u prime is 1, v is y, plus v prime is dy dx, u is x, so you have x dy dx. That's why we have this inside.
All right, thank you, sir.
Okay. So in the next session, we'll be looking at that type I gave you, which you all failed. That will be our first question. Second, functions of logarithms. So how do you differentiate logs? How do you differentiate? So the next session we'll do the logs, that question I gave you, and some trig derivatives. So if you miss, you'll miss a lot. I don't have to be missing. You get a point? Or you make sure that if you miss, you watch the video. Otherwise, we have no time to waste. And I didn't give you the exam. I haven't forgotten. I want it now to include derivatives. So it will be given, so the agreement will be September month end, exam 1. Here you can have difficulties. October month end, exam 2. Here, if you have difficulties in 1, here you need to improve. Then the last exam will be November, which will be exam 3. And November is our last month. December is for you to revise. Any days you'll be given, those are for you to revise alone or with your friends, not to learn. Because I'm very sure that in these, because when you fail exam 1, I'll burn you until you pass exam 2. And I'll burn everyone until you charge exam 3. Then I'll be at peace. And I'll send you in the exam. So that we end here.